Okay, continuing with increasing and decreasing functions, I'm now going to look at another example, which is question 2, part B. So the function here is 2x squared minus 8. So we've got a quadratic function now. The y-intercept is going to be minus 8. I want to sketch this. A nice bit of revision on how we can sketch quadratics. Okay, I could think about the roots. I find it easiest to know where the line of symmetry is. So the equation for the line of symmetry is x equals minus b over 2a. Now here, a is 2, b is 0 because we have no x term, and c is minus 8. So I've got 0 over minus 0 over 4, but it doesn't matter. If b is 0, then the line of symmetry is 0. Okay, this makes it really easy for me to sketch my function. So it's going to be a quadratic that's symmetrical about the y-axis, which is the line x equals 0, and its minimum point is at when y equals minus 8. So I know that at a minimum point of a quadratic, I momentarily have a gradient of 0, so f dashed of x is 0. So I can see here my function's decreasing, then for one moment it's flat, and then it's increasing. So I'm going to say decreasing for when x is negative, increasing for when x is positive. Job done. I could go into a bit more detail of this notation. I could say things like for x any real number and x is negative if I wanted to be a little bit more precise, but actually I think this is fine. Okay, if you did not know that there was a minimum point here when the gradient was 0, you could find it by differentiating and setting that equal to 0, and we'd get that point. If you didn't know what the shape of the graph was, then you'd get your calculator. But I really hope that at this point you know what a quadratic graph looks like and the different tools you have available to sketch it. I sketched this using the line of symmetry. You can also use the roots, you can factorize, use the y-intercept.